Welcome Voxxed Days Singapore. Great, I'm very happy to be here. I work for a tiny little company that you might know, and my name is Chris, and I'm going to ask you a bunch of questions during my talk, and the first most important question of the whole conference is, who in this room has a Twitter account? That's very nice. People in Singapore like Twitter. I like it. So I'm encouraging you, it's already day 2, so I'm a little late with the encouragement, but I encourage you to tweet about the event, the whole event, Voxxed Days Singapore. Use the hashtag on the, the banner over there. You see it, Voxxed Days Singapore, so that other people know how cool the event was, so that next year it will be bigger and bigger, and it will be recorded. So if you like the particular talk a lot, you tweet about it, say it was great, because later I guess you can watch it on YouTube. Probably not mine, but we'll see. And if you're going to tweet about my talk, use the hashtag TwitterVMteam, because Twitter actually has a VM team. So we are a small group of people, not so small anymore. I think we are 8 people now. And so 3 of our engineers are basically GC engineers. So they are taking care of all the garbage collection GC problems that everyone has every day. And we do too. Then I'm a compiler engineer, so I work on the JIT compilers. And should I start asking questions now? I think no, I'll do that later. So I work on the JIT compilers, and I do the fun stuff. I travel around and tell you how cool Twitter is and all the cool stuff we're doing. Then we have some people working on infrastructure things, testing. Then we have a tool called AutoTune, which is another talk I'm giving. It's a machine learning tool where we tune our services. So if you're interested in that, you can watch that on YouTube. So tweet about it, please. And so this talk, what's the goal of this talk? It is to save money, right? Everyone likes that. Who doesn't like money? All right, one guy in the back. So if you don't know me, my name is Chris. I work at Twitter now. I'm working on JVMs for a long time, and all these 14 years pretty much I'm working on JIT compilers. So I'm going to ask the questions now. Who knows what a JVM is? I just want to make sure. What do you know? So you know Hotspot, yes, the JVM of OpenJDK, good. Who knows what a JIT compiler is? Yeah, a bunch of people, okay. So briefly, in a nutshell, when you when you compile your Java source code or Scala or whatever into Java bytecode, into Java classes, then you start your JVM. The JVM interprets the Java bytecode for a little bit. That's very slow. And then there's something called a JIT compiler that compiles the Java bytecode into native code on the fly, just in time, right? So it's unlike an AOT compiler, ahead of time compiler, like GCC, where you get an executable. The JVM compiles it while you run it. So I'm working on these compilers, and Hotspot has 2 JIT compilers. One is called C1 or client compiler, and the other one is called C2 or server compiler. You might remember client and server that we used years and years ago. Don't do it anymore because we don't need it anymore. So these compilers are written in C++. And Graal, I think I have a slide later, Graal is actually written in Java. Okay, so I'm going to talk about this, and I work on this. I used to work at Sun Microsystems and Oracle on the JDK in the Hotspot compiler team. I mostly worked on C2, and then these 3 projects are like the biggest project I worked on at my time at Sun and Oracle. JSR 292, Invoke Dynamic. You might have heard of it. Maybe you're using it. If you're using Java 8 lambdas, you're actually using Invoke Dynamic under the hood. That's how it's implemented. The implementation, when we did JSR 292 back in a long time ago, before Java 7, the first implementation we had was a lot of handwritten assembly code, like pages and pages of assembly code, very hard to maintain. We had to port it to all the architectures that we supported, Spark and whatever, and all the other things. It was a major pain to maintain. We also had a performance issue, which we found out later. So basically we decided to rewrite the whole thing and moved all the handwritten assembly logic into Java, into a package called Java Lang Invoke. and that's where it all lives today. And a bunch, or a lot actually, of that Java code I wrote. So if it doesn't work, you could technically blame me. But I always say my code was perfectly fine, and people who touched it after me, they broke it. Chap 243 is a Java-level JVM compiler interface, also called JVM CI. We introduced this in JDK 9. And basically, as I said, Graal, the JIT compiler, is written in Java. And so Graal had an interface, like a JNI interface plus APIs, Java APIs, where it talks to the JVM, right? It needs to talk to the C++ part and vice versa so that compilation's happening. So we extracted that interface, put it in a module, in a JDK Java 9 module, and it's kind of stable-ish. It's not an official API or anything, but it's stable since 9. So pretty much if you compile a Graal jar file, you can use it with JDK 9, 10, 11, 12, 13. Works perfectly fine. So that's the interface. And we introduced the interface for Chap 295, which is ahead of time compilation. That's also, we did that in JDK 9. This is not native image. This is not Substrate VM or native image as you know it of Graal VM. This is something very different. This is basically a small command line utility where you can pass in class file or jar files, and then it takes the methods of these classes, passes it on to Graal, Graal compiles it, and it spits out a shared library at the other end. And then Hotspot can pick up these shared libraries, and basically you can skip the step of interpreting code, which might help. We did this mainly for startup performance improvements. If you have a very big application that runs a lot of different code, this actually might help. The main difference between this one and native image is this one is actually Java, while native image is not really Java. It's a subset of Java. And now I work at Twitter, best company on the planet. I hope you agree and tweet about that I said this, so I get more money. So what is Twitter? You might know that, right? It's a huge distributed system. We have hundreds and hundreds of microservices. The tweet service, obviously, we need to read and write tweets. Then we have a user service, timeline service, social graph service. These are kind of the biggest services that we have in terms of instance size. And we have many JVMs per service. We have, for the four I just listed, we have thousands of instances of them, right? Twitter is rather big. And then we have thousands of machines running thousands of JVMs in multiple data centers, right? We own our own data centers. So it's, there's some scale to it. We also like open source. We use a lot of open source. There is this Twitter, GitHub, whatever it's called, I don't know. It's like you can go there and then there are all the projects we've ever open sourced. So we like to use open source, but we also give back a lot to the community. And Graal is an open source project, at least part of it. And so it's a good fit for us, right? We can integrate it into our own JDK, and we're actually contributing back to the Graal project as well. We have our own JDK, which basically means we build our own JDK. So it's based on OpenJDK 8 update. Yes, we still run on 8. Who runs in 11 in production? A lot of people, like 0. Good. The difference between a regular OpenJDK 8 and ours is we backported Chap 243, the compiler interface, as I just told you, because we need it in 8. We have a copy of Graal. It's just a verbatim copy from GitHub. We just had to bring it into our own build so that, into our own source base so we can build it internally. We have something called Contrail. That's not so important anymore these days because Oracle open sourced all their proprietary code, right? All their closed features, so JFR is now open source. This is basically a re-implementation of JFR. We use this for logging internally. And then we still have some CMS improvements also. CMS is dead and deprecated. But a lot of people still use it, including us. So it's a good GC. So why Graal, right? Why are we running our stuff on Graal? Number one, C2 is a very old and very complex compiler. And trust me on this, I know what I'm talking about. I've worked on C2 for many years, and it's the most complex software piece I've ever seen in my entire life. So when it took me about 3 to 4 years to fully understand how C2 works in the JVM. And it's just ridiculous. So the learning curve is way too steep, especially today. Young engineers, they download a framework from GitHub and then they expect to understand that framework in like a week or 2 or maybe a month, and that's already a long time because then they're moving on to the next framework. This is very different. So we had, when Oracle acquired Sun, a bunch of our engineers left, right? They didn't like Oracle. And then we hired new people. And we hired a bunch of junior engineers right out of college. And some of them left us and after about a year and a half. And I can only speculate what the real reasons are, but I think one of the problems was they thought, oh my God, this is so complicated, I'm an idiot, I don't understand this, right? But in fact, it's that complicated. It just, people are not used to this type of complexity. So the other problem is the last few years, and I'm talking here because I'm giving this talk for a while now, this is probably already 4 or 5 years, we haven't done any major optimizations in C2, right? Escape analysis, inlining, loop unrolling, auto vectorization, all that stuff is there for many, many years, and we haven't improved on it. The only thing that happens in C2 is basically, except a small inlining tweak improvement for invoke dynamic, the only thing that always happens is Intel is coming out with a new CPU architecture, wider and wider AVX instructions, and then Intel's writing handwritten intrinsics. So an intrinsic is basically a replacement for some well-known method in the core libraries, right? Perfect example is string.indexOf, right? There's an implementation in the core library in Java, but actually what the compiler then does, or the JVM does, is it replaces it with handwritten assembly code, because you can implement it so much more efficiently with AVX 512, for example. So these are the only things that have been done in the last 5 years or more to C2. So in my personal opinion, C2 reached its end of life a very long time ago, and I was actively looking for a replacement for C2, and I think that Graal is that replacement. So Graal is much, much easier to understand. It has a modular design, modular not in the Java 9 module sense, but it was always designed in, you can see, there's like a screenshot from Eclipse. They have these, they call it projects. It's basically like a module, and the build system of Graal makes sure that you don't violate dependencies. For example, that architecture independent code doesn't depend on architecture dependent code, right? You don't want that. You don't want circular dependencies and all that stuff. So it's very well designed from ground up, the way it should be, exactly what C2 isn't. And then, very important at the bottom, Graal has a better inlining implementation than C2, and also a better escape analysis implementation. So people do know what inlining is? No, inlining, few people? Okay, so inlining, if you have a piece of code that's repeated multiple times in your source code, right, then what you do as a software engineer for maintenance reasons, you put that in a method, right, somewhere, and then you call it from multiple places. That's good, but from a runtime perspective, that's not the best approach. So what the compiler then does, it undoes what you did. It takes the piece of code and puts it in your caller. That's inlining. And that's a very powerful optimization. Inlining is the mother of all optimizations because it opens up the possibility of many more optimizations, like escape analysis. Escape analysis, people do know it, probably not what escape analysis is. I'm not going too much into detail, but it can get rid of object allocations if the compiler can prove you don't need it. So if it's not escaping your compilation unit, if you're not passing an object around or expose it into like a global state, the compiler can get rid of it, and that means you don't have to allocate that object. That means tighter code, but more importantly, you don't have to collect the garbage later. Very powerful. Okay, bugs. So when we started running our services on Graal, we found a few bugs. I'm going to walk you through them so you get an idea what we found. So the first bug was Graal should support some OSR compilations as C1 and C2. I'm not explaining to you what OSR is. It means on-stack replacement. So it doesn't really matter. So I was running the tweet service and I was turning on print compilation to see what's going on. And there was this logging output called compile skipped, OSR with logs not supported. And I thought, okay. And then the exception looks like this. It's very nice because since the Graal is written in Java, you actually get an exception and you know what the hell is going on and where it's coming from. And you can see at the very top, there's a phase called on-stack replacement, all right? And then it does stuff. And there's an engineer called Tom Rodriguez. He works at Oracle Labs. And so we discussed the situation of this. And then we decided after a while that this is not a big issue in general because tiered compilation will take care of that, kind of. Do people know what tiered compilation is? No? No one? One person, maybe. So remember when I told you about C1 and C2? I did not explain what C1 and C2 are. Okay. You remember C1 and C2, the JIT compilers in Hotspot? So C1 is a high throughput compiler. It doesn't do a lot of optimizations. The purpose of C1 is to get away from interpreting code and running on native code as quickly as possible. And then you run on C1 code for a while. The way we compile it is we compile the code and we also compile in some extra code that collects profiling information. It collects how often was the method called, how often did we execute a loop, what types did we see, which if-else branches did we take, things like that. And then later, we run on that code for a while, collect information, and then later we recompile with C2 or Graal, the top tier compiler, and that gives you the peak performance code. And so you're stepping through the tiers, that's tier compilation. So in this particular case, if the top tier compiler, C1 or Graal in this case, cannot compile the method, we still have code compiled by C1, right? We're not interpreting it. So that's why it's not a big issue. The method will be flagged after a while and said, oh, I can compile it with tier 4, and then we just run on C1 code. But it still would be nice to get it fixed. And actually someone did. It took, at the bottom, you can see 14 change files, 1,000 lines of code to fix that problem, right? Which is quite a lot. And then technically it's still open, right? Because I was running, I took in the patch and I was running the service again to verify that it's actually fixed. But I saw these other, you see permanent bailout exceptions that basically Graal bails out of the compilation for some reason, and then we discussed it. And you can see Tom saying at the bottom, there's a little piece of logic in C2's parser which allows access to static fields within the CL init, the static class initializer, for classes which aren't fully initialized yet. You see, it's kind of a chicken and egg problem. This is the little bit of parsing logic in C2. You can see the method is called static field OK in CL init. This is already, because the problem is we're trying to access a static field or the value of it while the class isn't initialized yet, right? So, but since we are the compiler, we are the JVM, we can trust ourselves, and that's why it's okay for us to access it, right? The problem with this one is a static class initializer is executed how many times? Once, exactly. So if we are going to compile a static class initializer, that means either it's very long or it has loops in it, right? Both of them are really bad because very likely a lot, maybe not all of your threads of your application, but a lot of them probably wait for that class to be loaded and then continue. So you're basically stalled. So if we compile it, and then there's this comment, the second line of the comment, this one, better to check now than to de-optimize as soon as we execute. So de-optimization is, in a nutshell, basically, C2 and Graal are speculatively optimizing compilers. So basically what we do, we assume things when we compile with all the knowledge we have at that point in time, and then run that code. But the assumptions that we had during the compilation might be invalidated later. That happens, for example, if we load in another class and our class hierarchy changes. And then we have to kick out the compiled code, and that's called de-optimization. If we hit a situation that we did not expect. So we fall back to interpreting code. So in this particular case, it would be really bad if that would happen, because we already ran the static class initializer in the interpreter for a very long time, then decided to compile it, and then we compiled it, and then we run on the compiled code, but then we immediately de-optimize and fall back to the interpreter, so we wasted a lot of time. So this is very important from a performance perspective. This was fixed with 31 lines of code, because it was that tiny little piece that said, yeah, it's okay for you to get that value. So that was pretty easy. Then I had this one, fatal error, basically a segv, so the whole JVM crashed. The problem, as you can see in my comment, that was September 1st, 2016, so a while ago, with long-running processes, couple days. So I had to run the tweet service for a couple days for the thing to actually crash, which is, not very nice. Then I was looking at, okay, what are we passing to the JVM? And I found that we're actually using an agent called Heapster, and Heapster is available as open source on GitHub. It's an agent library to do heap profiling. Interesting, heap profiling. So heap profiling, the way heap profiling works, it does bytecode instrumentation. It instruments new bytecodes. So whenever do a new object or new array, whatever, it records type, right? The problem with that is Graal is written in Java. So it also instruments Java code of Graal. And so there was a discussion between Doug and Tom here. As you can see, Doug at the top says, bytecode instrumentation agents, in this case, the bytecode of double dot value off. If you do double dot value off, it does a new. There is something in Graal called snippets. It's similar to what I explained earlier with an intrinsic. It's just snippets are written in Java, right? Graal parses the Java code. It uses Java as a DSL in that particular case. It parses that code slightly differently and then adds it into your compilation. That's kind of how it works. And so they're discussing this. So when that bytecode is being instrumented, that snippet, and that leads to the issue. And then at the very bottom, Doug says, then maybe it's time to bite the bullet and parse the bytecodes for snippets directly. Okay, so they did this. Took 2,800 new lines of code to fix this problem. But the important part here is, this is very important, right? The compiler has been around for years at that point in time, but Oracle is running their tests in SpecGBB, right? They're not using agents, but we in the real world, we do, right? So very important bug to fix. Then, this one, we had some, for the longest time, here we go. I was running, I think, again, the tweet service, and every now and then I saw connection exceptions flying by in the log. And I had no idea where they were coming from, because I have no clue about microservice architecture and stuff. I'm a compiler engineer. I don't know anything about this. And I didn't know where to start to look for, right? Microservices are very nice, sure, but if you're looking for a problem, it's hell, right? Because if I get a connection exception in my service, I don't even know if it's me or the 100 other ones I'm talking to. I didn't know what to do. So I thought, okay, well, whatever. I dropped this for a while. Maybe I'll figure it out later. And then independently, I think we updated Netty, an internal version of Netty. And I thought I'll run the Netty tests. And then Netty buffer, boom, failure. I thought, okay, that's interesting. Maybe we should look into this. And it turns out there is a method on the number class called reverse bytes, right? So there's integer.reverse bytes, it just reverses the bytes, and short.reverse bytes, that's the one here, that just reverses the bytes, right? The byte ordering. Turns out that was wrong, right? Graal compiled the code for short.reverse bytes wrongly, which is ridiculous. To this day, I don't understand how this could work, years and years before in every other case, but just this one, it didn't work. And then, Tom found the problem. It was basically a copy-paste error. It was 2 lines, I think it was 2 lines, 68 lines fixed, but it was 2 lines actual fix and then a test case. It's ridiculous, but that shows you it's very important, and I'm going to talk about this at the very end when I'm, begging you to run Graal as well, it's very important to run different code shapes with the compiler to find these edge cases. All right, that was all we found. And the last one, let me go back, when was that? September 2016. Since then, we haven't found a single bug, right? And we are running the tweet service, the social graph service, the user service, and about 20 other services, 100% on Graal in production right now. So for I think the tweet service for about 2 years now. So if you ever have tweeted or seen a tweet in the last 2 years, it was served to you by code compiled by Graal. And it's very stable. We never saw a crash. Did you lose any tweets? I did not. You would not even know if you lost a tweet, but you did not, believe me. So contributions, I'm talking about one contribution that I did. My colleague Flavio, he's actually doing much more interesting contributions, so to say, because he's working on Scala-specific optimizations in Graal. Very interesting. This one I did a while ago. JDK9 has compact strings, if you know that. And the way Oracle decided to implement it, and I was very upset about this, and I tried to argue against it, but I wanted the implementation, because you need to compress bytes and stuff, right? The way I wanted them to implement it was with unsafe. Because if you implement it with unsafe in Java, every compiler can just compile the code and optimize the shit out of it. But they decided, because C2 could not optimize it the way they wanted it, so they decided to write all the intrinsics by hand, which means we have to port all the intrinsics over to Graal. So I started doing one of these, and for the string.compare2, this is a benchmark that I use to verify that the performance is the same than with Graal and C2. The third line, the third line is basically the most interesting one. It's like the score is 2,600 with regular Graal, and then Graal with the intrinsics that are ported, it's 126. It doesn't really matter. The important thing is here, the performance of Graal with the intrinsics is exactly the same as C2, because it's the same handwritten stuff. The problem is, and I actually didn't finish that thing, it was Dimitri who fixed it eventually. It was 1,000 lines of assembly code that I had to port over. Very annoying. Maybe at some point in the future we can revisit that, but currently that's the way it is. So that was one thing we contributed back at that point in time. So numbers, that's the interesting part. We're going to look at the tweet service. The tweet service is a Finagle thrift service. So Finagle is one of these open source frameworks that we have where we build our microservices. And it's an extensible RPC system for the JVM used to construct high concurrency servers. I have no idea what it is. I have no clue. I don't have to know. The important thing is at the bottom left, you see it's 92% in Scala code. So almost all of our microservices are written in Scala. Basically, the stack looks like Netty, Finagle, and then the logic of the service. And I think we have a handful or so services that are written in Java. All the other ones are written in Scala. The test setup, if you're doing performance benchmarking, especially when you only expect single-digit percentage improvements, it's very important to have dedicated machines. If you're going to do your benchmarking runs in your data center, on your shared machines, all your results will be in the noise, right? So I have dedicated machines. All of my machines receive the exact same requests. It's very important, not only the same number of requests, the exact same request. It's very important in the case of the tweet service, because a tweet could be 1 character long or 280. And the memory allocation pattern would be very different, right? But we want to compare apples to apples, so all of the instances receive the exact same request. And this is actually, because I get this question quite a bit, this is real world live request data. So I'm not replaying anything, or this is not some testing data. It's what's coming in right now. It's part of the requests that are coming in. We run this JVM CI version, this Graal version, default tiered C1 Graal setup. Who knows what tier compilation is? I explained it earlier. All the hands should go up. Ignore this for now. Graal bootstrapping is not an issue. I have another talk where I explain all this. Just trust me, it's not an issue. Okay, that's it. That's 24 hours of tweet requests. And then we have at the bottom, when I created that slide, the slide deck, you can see we all expected JDK 9 to be the next JDK version. So JDK 9, the Java no one ever used, right? So we're comparing blue is C2 and orange is Graal. These are the two that we're looking at. Important thing in this graph is all the requests are the same, right? So the first thing we're looking at is peer scavenge cycles, so GC cycles, because, as I said earlier, Graal's escape analysis is better, so we would like to see less memory being allocated, which translates into less GC cycles. All right, so this is C2, this is Graal. We can certainly see it's less, and then the JDK 9 versions. And this is an improvement of roughly 2.5%. So by running the tweet service on Graal instead of C2, we have 2.5% less GC cycles. It's not a lot, right? But it's nice to have, because remember, we're still doing the same amount of work. And GC cycles always affect your latencies. So the less cycles you have, your latencies are better. Then one thing that I should mention is some of our service owners actually noticed that because they're looking at their metrics really closely. Since Graal is written in Java and runs in your JVM today, it uses some metaspace, right? Because you're loading classes, right? It has to use some memory, and it also uses some old gen memory because it has some state. It doesn't have a lot of state because compilations are basically stateless, but still, it has to build up a little bit. And this is, as you can see, there's a slight difference, but it's only roughly 40 megabytes. So, and it's 40 megabytes, right? It's not a fraction of your old gen. If your old gen is 100 megs, it's 40. If it's 2 gigabytes, it's 40, right? It's just the state of Graal. But it's good to know to not freak out. Memory leak. It's not. This is the one I care the most about, user CPU time, because what I want to do with my work is I want to reduce user CPU time. The reason is if we can do this and use less CPU to serve the same amount of tweets, we can shrink our instance size, right? That means money. Yeah. So this is C2, that's Graal, certainly better. We can see that than JDK 9, and that's an improvement. Yes. So the reason this slide deck, you see there's no y-axis. The reason why there's no y-axis is because I'm not allowed to tell you the ranges and numbers of these things. So highly confidential information you're seeing here. Don't take pictures. Please take pictures. So I showed it in a different graph, like in a ratio graph, and you can already see how much it is. One very interesting thing in this ratio graph is it's completely flat, right? So the improvement, the user CPU time improvement does not depend on the load. And this is 11%. And 11% improvement is ridiculous, right? I mean, for you, it might not be as much, but if you deal in compiler stuff and compiler optimizations, you're happy when you get 1%, right? If you get 2%, you get home and get drunk because it's great. 11 is a lottery win. I did not expect that. So that means for the tweet service of our thousands of instances, what we have, we can remove 11% of these machines, which is, again, a lot of money. So I already mentioned this, that the tweet service and the other services run on Graal in production, plus a bunch of others, the social graph and the user service, so skip that one. Is it escape analysis? So I was interested in that answer because basically the two things that are better in Graal than in C2 is inlining and escape analysis, the things I kind of explained to you earlier. So I wanted to see how much of the improvement is actually coming from escape analysis. So what I did was I took the tweet service and turned off escape analysis for both compilers. Because then, technically, GC cycles should be the same amount of memory being allocated, and then we see the improvement. So this is a different 24-hour run of the tweet service with escape analysis turned off. GC cycles, that graph is just to verify that there is no difference, right? So same GC cycle, same amount of memory allocated. And that's the user CPU time. And it looks like this. And that's the ratio. And you can see it's less than it was before, obviously. It's 5%. that was very interesting to me because basically I was expecting escape analysis to be much more, but only just the inlining plus maybe a few other optimizations that I'm not exactly sure how much better they are, give you half of the improvement. So even if your service, you cannot escape analyze a lot of the memory allocations, you still get a very nice improvement out of it if you run on Graal. So how much money are we talking here, right? I can tell you, of course not. I cannot even show you a y-axis. Why do you think I can tell you how much money we're saving? So just to give you an idea, we're making up this fictitious company that does not exist. So what I did was, maybe you are using a cloud provider and you have kind of an idea how much that costs. I don't. So I was Googling for a bunch of cloud providers that actually give you numbers on the web. I'm sure these are a little too expensive. If you would buy more machines, it would get cheaper. But I basically calculated it out, and it's between $72 per core per year and $210. So if you're going to take away one thing from this presentation is, if you pick the wrong cloud provider, you don't even have to run on Graal because you're wasting so much money, right? So pick your cloud provider wisely. So I thought, okay, let's take the average of $127 per year per CPU core. So how many cores are we talking here? There is an article, a Bloomberg article from 2014 that talks about how many servers Amazon has, and they expect either 1.5 million or 2 million servers. And then at the bottom they talk about Google and Microsoft. Microsoft says over 1 million servers within its data center infrastructure, and that Google had even more. And that was 2014. That's 5 years later now. So it's probably 10 times as much, I don't know. So it's a huge number that we're talking about, right? So let's assume, because our company is certainly smaller than Google and Amazon, so let's say we have 1,000 servers. It might be still too big for a small company, but you know, it's a reasonable number. And each CPU usually has 24 cores, right? So we're talking $127 per year per CPU core times 24 times 1,000 is $3 million to just run your business, whatever you're doing, right? Let's assume it's a small Twitter, $3 million to run it. 11% of that is $330,000. It's a lot. It's more than I get paid. I'm not sure how much you get paid, but it's certainly more than I get paid. So this is a huge chunk of money. And usually, if your business is online, right, and you provide some service or whatever, even if your company is small, the expenditure for your compute is usually a fraction of your revenue, right? So even if you only have, I don't know, $10,000 of expenses for compute per year, and you save $1,000, that's a great Christmas party, right? So, you know, use it wisely, the money you save. So can we get more improvement? I was interested in that, and the answer is yes, we can. Can we tune Graal to get more improvement out of it? So what I did was, I sat down on Friday afternoon for about 3 or 4 hours and tuned 3 parameters of the compiler, inlining related parameters, and this is the outcome. It's actually something that you shouldn't be doing, right? There's a talk that I'm doing where what is it called? Performance tuning Twitter services with Graal and machine learning. So we have a machine learning thing that does that. Watch that talk on YouTube if you're interested, because it does a much better job than me as a human. So this is the same requests per second graph you've seen earlier, and then there's this new one which I call experiment, the purple color. And you've seen that graph before, the scavenge cycles, and this is my run, my improvement basically, and I could squeeze out another 1.5% up to a total of roughly 4. Which is pretty nice. We have 2.5 before. I tuned it a little bit, another 1.5. So performance tuning is really, really important. And this is user CPU time. Looks like that. Certainly an improvement. We can see it. How much is it in the ratio? It's another 2%. So 2% is great. You remember the last graph? Out of the $3 million, that's $60,000 in an afternoon. I wish I would get that money, right? I've actually asked Twitter, and they said no. But so performance tuning, very, very, very important. Any official Graal support, it's getting better now, right? I wrote these slides about a year and a half ago or so. One thing is, so even JDK 9 contains already Graal, but because of this AOT CHEP 295 thing I told you about earlier, right? You can use it since 9 as a JIT compiler by just passing in these command line flags. I had a very, was it this year or was it last year? I think it was last year. I gave a presentation at FOSDEM in Brussels, and then Mark Reinhold, the architect, was there. And I gave this presentation, and I said, oh yeah, you can use Graal as a JIT compiler in JDK 9. And then after my talk, we chatted a little bit, and he said, I didn't know you could do that. And I said, well, I made it, you could do it that way. I didn't tell anyone, but I made it that way. But it's even better now, because there's CHEP 317 experimental Java-based JIT compiler. So in JDK 10, Oracle decided, okay, let's officially make it an experimental JIT compiler. It's still not, the Oracle supported way, but this means if you run it and you crash, they'll at least fix your problem, right? They'll not reimburse you for the money you lost, but at least they will fix your issue. So since 10, if you're running on 11, and I think there were a lot of hands up earlier when I asked the question, so you can just turn it on. There is also, if you want to run with Graal on 8, and we do that too, you can download, for example, the Graal VM Community Edition. You can also download the Enterprise Edition. I'm not saying you shouldn't, but keep in mind, you have to pay for it if you use it in production. I'm not saying don't pay for it. I'm just saying I don't want you to get sued by Oracle, right? So be careful. There is this talk, how to use the new JVM JIT compiler in real life. It's basically where I explain that's the current situation. It will change in the future, but currently you have two things. I don't want to call them issues, but there are two things you should know about Graal. The one is the bootstrapping, because since Graal is written in Java and it's the compiler in your JVM, it needs to be compiled when you start up. So it's like a meta-circular approach, and that takes a little bit of time, right? Because it's additional compute that you have to use. So, and then the other thing is, C1 and C2 are written in C++, so memory allocations for JIT compilations happen in the native heap with malloc, but Graal allocates memory on the Java heap. It's just something to remember especially when you run benchmark runs or whatever, that you interpret the numbers that you're seeing the right way. So watch this one if you're interested. And then there is something called Project Metropolis, which John Rose proposed in September 2017. And down there it says, our starting point is earlier proposals for using the Graal compiler and AOT static compilation technology to replace the hotspot server compiler. Yay, we want to get rid of C2 because it's a piece of shit. And possibly other components of hotspot. So Metropolis aims at replacing parts of the JVM with things that are written in Java instead of C++. The perfect one feature to replace off a JVM is a JIT compiler, because it's the only optional component, right? A JIT compiler is just an optimization. If we didn't have JIT compilers, which Java 1.0 didn't have, you just run interpreter. It's freakishly slow, but it works, right? You could not run without a GC, or you could not run without a class loader. You know what I mean? So, but parts we can write in Java. For example, the bytecode verifier would be so much better to implement in Java. I really would like to implement the interpreter in Java. So a bunch of things. If you're interested in that, please help out. It would be cool. Okay, so this is kind of my last slide. I have to state this. So the improvements we're seeing are really, really nice. But one of the main reasons why we're seeing such a big improvement is because our stuff is written in Scala. Scala, when you look at the bytecode, and it's more a little bit of functional programming, and it allocates a lot of temporary objects, which escape analysis can get rid of. You see where I'm going? Graal does a really, really good job with Scala code. It can also optimize your Java code, and I've ran internally our microservices that are written in Scala on Graal, and we see improvements with some of them as well. It's kind of a 50-50 chance if your Java code is faster or slower or the same with Graal. The reason for this is C2 has been around for a very, very long time, like 15 years or something, or even more. And I've worked at Sun and Oracle on C2 many years, and not a single day or a single hour or a single minute did we optimize for any other language than Java, right? So if you're running anything else, Scala, Kotlin, Clojure, Groovy, you might try Graal, right? So C2 was always optimized for Java, but most importantly, you optimized your Java code for C2 because you wrote it that way that it runs the fastest on what you have. And so it's very difficult for a new compiler to come in and be better everywhere, right? I have no benchmarks. I can give you the name of benchmarks where you can see that Graal runs Java benchmarks faster. I know some where it runs slower. Most of the time it's about the same performance. And that's already a win for the whole Java ecosystem community. Because we want to get rid of that very complex compiler, replace it with something newer where we can do more optimizations and where things like this can happen, right? And then on top of it, if you watch my other talk, you will see what performance tuning can get out of Graal. And then on top of it is, like my colleague Flavio, doing language-specific optimizations. We could do that in C2 as well. It would be just so much more work. Right? In Graal, it's so much easier. So we want to move to this summary. So the summary of my talk, this is the summary slide of all of my talks. It's the same. I'm doing all these presentations. I'm not getting paid by Oracle to do this, right? This is great technology. I love it. I get paid by Twitter to do it, so that's okay, but not by Oracle. I'm doing these presentations because I want to encourage you to try Graal as well. The reason, there are different reasons why I want you to do this, but the one reason is I want you to save money as well. I'm a very nice person, right? We are saving a lot of money, you should save money too. And then if you do, and I come back to Singapore next year, you'll buy me a bunch of beers or whatever, or I can sleep at your house, or the other reason is, and that's actually the reason, I want Graal to become the default compiler in OpenJDK. The problem is Oracle is a very conservative company, right? And rightly so, I would say, because the whole world runs on Java. All of the money and the stocks you have in your bank accounts is probably managed by code written in Java. So we have to make sure that it works, right? The problem is Oracle thinks that Graal is not mature enough to become the default compiler. So it's not default in OpenJDK or Oracle JDK, so that means it's a chicken and egg problem, right? If people are not using it because it's not the default, no one's using it. But Oracle won't make it the default if no one's using it. See the problem? That's where you come in. I've done my part. I soon will run all of Twitter on Graal. Then I'm done, and then I retire. No, not yet, but soon after. And I want your shitty production code to be run on Graal. That would be cool. Because you have that weird code that's been around for a while, weird code shapes. It doesn't have to be, too big. It could be, if you have a pet project that you're working on, that the size of the project doesn't really matter. It's only that the code shapes matter, right? We need to throw a lot of different code at the compiler to find all these weird corner case bugs that I showed you earlier. And we haven't found a bug in over 2.5 years now. So please, 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 on Monday, if you go to work and you run on JDK 11, as everyone said they did, just turn on these flags and run it in production. That would be cool. No, you will have, like everyone, including us, you have a staging environment or whatever, right? Something where you try things out. If you're running on an Oracle JDK or OpenJDK build, you can just download, as I said, let's say Graal VM CE, that's Java 8 version, and use that instead and see if you see an improvement or not. If you do see an improvement, please let us know. Tweet it out, or write a blog post or whatever you want to do. Post it on LinkedIn, because apparently people use that here. I don't even know what it is. If it works about the same performance, please also let us know, right? If it's worse, let us know as well. And if it's code from your company, it's probably difficult, because it's proprietary code, I'm assuming. It's probably difficult to give us the code so we can take a look at it, but maybe you can extract a small test case so we can see what is the issue, because we want Graal to support all the performance improvement, code shapes, whatever C2 supports. So we have feature parity and everything. If it crashes for you, perfect. That's exactly what I want. Because if it crashes for you, found a very serious bug. And that means we don't find it. Because if Twitter is down, we all are sad because we can't look at our cat pictures and cat videos and stuff. So please, please, please give it a shot. If you have any questions about how to use it or whatever, ping me on Twitter, send me a DM. My DMs are always open if you need help. You can also tweet out at GraalVM or with the GraalVM hashtag or Graal hashtag. So someone will get back to you and help you out if you need help. That's all I had. Thank you very much. I'm not sure, are we doing questions or? We can do questions if someone has a question. Yes?
Just a question. When you saw 11% of improvement,
yeah.
did you think it was a mistake somewhere?
No. Because the reason why, because the tweet service worked. So all the graphs you've seen, I've not created these graphs. It's a screenshot of our internal monitoring system. So if it wouldn't work, I would see that it doesn't. No, I was just very surprised that it's that much. Yep.
Was the 11% because of Scala, or would it work?
It's basically because of Scala, yes. It's, as you've seen, it's like a 50-50 between escape analysis and other optimizations. I'll put it this way: if you watch my other talk with the performance machine learning thingy, I'm doing the tweet service and the social graph service. And the tweet service is about 11-12% improvement, and social graph is 5 to 6. So it depends. And social graph has the same Netty finagle stack. It's just the logic on top is different, the service. And it just depends what your code does. If it allocates a lot of temporary objects and throw away things, the compiler can take care of this. Otherwise, so your mileage may vary basically. But Scala, if you run Scala code today and you're not using Graal, you're an idiot. Because 100%, I give you 100%, or I give you money, it will be run better on Graal. I've never seen any Scala thing that ran worse on Graal.
It's still more to immutability and allocating an object every time. But due to things that in Scala usually you're not mutable variable.
Right, exactly, yes. That's one of the reasons. The other reason is, and you cannot really influence, basically what you said, that's it. And the way it compiles it to Java bytecode, if you look at Java bytecode that's generated for Scala or Java, it's very different, right? It allocates all the stuff underneath you that you have no control over. That's where Graal is winning, yeah. Sure.
Ninth question. So, say if I want to use Graal tomorrow, do I have to compile my Scala code or Java code through the Graal SDK?
No.
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 So
There's
basically turn on the compiler.
Yeah. All, the flag stuff, that's all you have to do. It's yeah, I know people are a little bit confused lately because they think, native image and blah, blah, blah. So this has nothing to do with it. It's just a different compiler in the JVM. It's like using a different GC. If you use, CMS instead of parallel GC, it's the same. No, it's 100% compatible. You first. Yeah.
Just curious, how just now, like we said Scala, why does Scala make it faster? I mean, isn't it immutable? Make it have to create new object every time? And other than the recursive tail optimization, I mean, what can make Scala faster compared to the same in Java?
Right. So the hotspot doesn't have tail optimizations or anything like this, right? But what you just said with the creating new objects, that's exactly the problem. But these objects that you are creating, you are usually not publishing them globally, right? So if these objects that sometimes you don't have to, you not allocate them explicitly, right? They're created for you behind the scenes. They rarely escape your method, right? And if they're only in your method, only used in your method, you don't need them, right? That's where the whole improvement comes in. It's escape analysis.
Are you running the search engine as well with Graal?
The search engine?
Yeah, that you have at Twitter.
I don't think so. It's slow, right? And it's shit. I know Twitter search is the worst. I don't think we do. I'm not sure which service that is. I would have to go back and find out what the name of the service is, because I kind of lost track a little bit what's running on Graal now. But the next big step, and I think we are ready to do it because JDK 11 came in between, that was higher priority. We will move everyone to a Graal in Twitter pretty soon.
Because I know that you are using a specific version of Lucene that you modified yourself.
Probably.
Lucene is one of the projects which is finding a lot of bugs in the JVM. So
Are you talking about Java 7 here? What do you mean? No, Lucene, we had some issues with Lucene. Yeah, it's a very nice framework to find compiler bugs. Yeah, it's true. Yeah, it is. Any more questions? You can ask me questions. I'm around. You can ask me later. All right. Thank you.